Selenium 4 has been released. It's official. This blog post speaks about how it's a drop-in upgrade while keeping the public APIs stable as possible. It also mentions some new features such as the Relative Locators and new capabilities for Firefox, Chrome, and Edge. Chrome and Edge are Chromium-based browsers. The Grid has also been rebuilt. In this video series, I covered nearly all of the new Selenium 4 features. If you want to skip around the video, then go to the description to see a link for each new feature. You can download this document, which is the transcript that talks about Selenium WebDriver, Selenium IDE, and Selenium Grid. The table of contents shows W3C WebDriver protocol. It's the new architecture for Selenium WebDriver that does not include the JSON wire protocol. We see the relative locators that locate elements in relationship to another element. The element can be above an element, below an element, near an element, to the left of an element, and to the right of an element. Selenium has ways to manage a new window, new tab, and minimize a window. The getRect method is a combination of the X and Y coordinate plus width and height. We can take a screenshot of the WebElement and a full page screenshot using Firefox. At the end, I covered the CDP. CDP stands for Chrome Debugging Protocol. It's also an acronym for Chrome DevTools Protocol. It doesn't matter, they both are the same, which is CDP. The source code and document have been placed on GitHub. So if I go to GitHub, we will see how starting at video 148 and stopping at video 167 has the source code and document. And I plan to add the document to my website. Now, let's get into the video of Selenium 4. Hello and welcome. In this series, I am going to demo some features that have been added to Selenium 4. All components in the Selenium family have a new feature: Selenium IDE, Selenium WebDriver, and Selenium Grid. Selenium IDE is the component that allows us to record and play back our test. Selenium WebDriver is an API that allows us to create and execute our test scripts by driving a browser. Selenium Grid is a way for us to run our tests in parallel across more than one browser, across more than one operating system, and across more than one machine. The main reason for upgrading from Selenium 3 to Selenium 4 is the W3 WebDriver is the W3C WebDriver protocol. It's the new architecture for Selenium. I will discuss new features for the complete Selenium family suite: Selenium WebDriver, Selenium IDE, and Selenium Grid. For Selenium WebDriver, I am going to explain the new Selenium 4 architecture, W3C WebDriver protocol, then demo the Relative Locators. Relative Locators is a way to locate an element depending on the position of another element. Next, I will demo how to handle a window by switching to a new window and by switching to a new tab. Then take a look at getRect. getRect was implemented as a combination of getLocation and getSize. We will also take a screenshot of a WebElement. Last is the Chrome DevTools protocol, which helps us to get the development properties. Although there are 3 components in the Selenium family suite, when we only say Selenium, we are referring to Selenium WebDriver. Therefore, Let's start with two drivers that have an update: Chrome driver and Edge driver. Both drivers now extend Chromium driver. Also, both browsers, Chrome and Edge, are built on the same Chromium platform. In Selenium 3, all of the drivers, including Chrome and Edge, extended the remote web driver. However, with Selenium 4, Firefox driver, Internet Explorer driver, Opera driver, and Safari driver extends remote web driver. In fact, Chromium driver also extends remote web driver. Remote web driver is a way to run our tests remotely, but we have to configure our tests. The benefit of Chrome driver and Edge driver extending Chromium driver is access to the Get Devs Tools method. Let me search for Get Dev Tools, and we see the Dev Tools class with Get Devs Tools as the method. This method will allow us to diagnose a problem and track what's going on in the browser. There's also a change to two methods in the Fluent Wait class. On the left side, we have Selenium 3, and on the right side, we have Selenium 4. The with timeout method and polling every method no longer have two parameters, long duration and time units, but they have been replaced with only one parameter, duration, in Selenium 4. Even the finds by interface, this here, the finds by ID interface, have been deprecated and removed from Selenium 4. The other finds by interfaces, which is finds by class name, finds by CSS selector, finds by link text, finds by name, finds by tag name, and finds by XPath, have also been removed from Selenium 4. Here's a web page that shows more deprecated APIs for Selenium. If we just scroll down, we see some of the methods we already mentioned that's been removed from Selenium 4. But this page will give you a list of what has been removed from Selenium 4. Next are the new features for Selenium IDE, and I'll see you in the next session.
Part 1 ebooks and PDF documents are free. Programming books for UFT. Programming books for Java. Here's the Selenium automation book. And TestNG. Subscribe to get notification of future videos. Don't forget to like, comment, and share.
When it comes to Selenium IDE, the purpose is to record actions we take on a website, then play back those actions from the website. In the past, Selenium IDE was only available as a Firefox extension, but now it's available as a Firefox extension and Chrome extension. Microsoft Edge will be available soon as an extension. There are plans for Selenium IDE to be available as an Electron app. The Electron app will allow us to use the debugging protocol and listen out for events from the browser. Some new features include the backup element selectors, control flows, and the command line runner, also known as CLI runner. The backup element selectors record more than one locator for each element. If we execute a test that does not locate an element, then this feature will fall back to a different locator until the element is found. For example, our test runs and it cannot locate an element using a link text locator. The backup element selectors with a check to see what other locators were recorded for this element. Then grab another locator such as ID, XPath, or CSS selectors. There are two types of control flows. We have conditional branching and looping. The conditional branching flow decides what happens next if a certain condition is satisfied or not satisfied. Loop control flows execute an instruction for a number of times. We see the commands for each flow are if, else, and end for conditional branching, while looping has times, do, while, and for each. The command line runner, also called Selenium side runner, allows us to run our tests on any browser: Chrome, Edge, Firefox, Internet Explorer, and Safari. In this first sentence, it says in parallel and on a grid without needing to write any code. That's why we can imagine Selenium IDE as an on-ramp to the Selenium family, because little to no programming knowledge is required to start automating our test. By the way, the new name is called Selenium IDE TNG. TNG is an acronym for the next generation. So the complete name is Selenium IDE, the next generation. Do you see code export under introduction? Code export is not a new feature, but it's a good feature that pushes code to Selenium WebDriver in your chosen language and test framework. To export, all we do is right-click a test or suite, select export, then pick a supported language, test framework, and click the export button. Oh, I almost forgot. Selenium IDE has a way to create new commands as part of their plugin system. Those plugins can be delivered as an extension. A big shout out to Apple Tools, because they are the ones who revived Selenium IDE and has a plugin that makes it possible to perform codeless visual browsing, visual testing. We can also reuse a test case, implementing a run command. The run command executes a test from within another test. They also have another command called store, and store allows us to save a value that we can reuse later. Last but not least is continuous integration and debugging. Selenium Side Runner assists with integrating our code continuously into a shared repository. The debugging feature allows us to set breakpoints to pause our test at a certain point, play our test to a certain point, record our test from a certain point, and play our test from a certain point. Next, let's talk about the new features for Selenium Grid, and I'll see you in the next session. Thank you for watching. The new feature for Selenium Grid involves a brand new architecture. On this selenium.dev page, we see Grid 4 has an approach to take advantage of a number of new technologies. You can browse these sections for more information about the components, understand how the grid works, and set up the grid. Let's discuss the components and how the grid works. We have a client, router, distributor, session map, node, and event. Also, GraphQL has been added as a new way to query and get data. I'm going to get straight to the point and discuss these components. The router's role is to listen for a session request. We see the router has an arrow pointing to the distributor and pointing to the session map. If it is a new session request, then communication starts between the router and distributor. If the session request already exists, then communication is between the router and session map. When it comes to the router and distributor, a session request is sent to the distributor. The distributor is responsible for selecting a node to run our test. This diagram shows one node, but in reality, we set up more than one node. The node can be a physical machine or virtual machine that execute our test scripts. After the distributor selects a node to run our test, the node responds back with a URL of the session. At this point, a session is created and the distributor sends information to the session map. The session map is important because it maps the session ID. That's how the grid works when there is a new session request. When the session already exists, the router sends a session ID to the session map. In return, the session map sends the node that has a running session back to the router. For subsequent steps, the event bus operates as a path for communication to other grid components. In addition to the new architecture, Selenium Grid is more modern and has observability. By it being more modern, we can leverage up-to-date technologies like Docker and Kubernetes. With Docker, our applications can run in containers and not worry about setting up virtual machines. Kubernetes allows us to scale using a cloud infrastructure. Observability helps us to trace, log, and measure what's going on with the system internal state. There will be a trace ID when a request comes in to help developers and admins debug a problem. That's it for the new features for Selenium Grid, and I will see you in the next session to discuss the new W3C WebDriver protocol for Selenium 4. And you have a good day, and I apologize for my phone ringing because it's time for me to go to work, and see you in the next session, and thank you for watching. The W3C WebDriver protocol has at least 3 advantages. Number 1, it provides standards. Number 2, it provides stability. And number 3, it provides an updated Actions API that is supplied with better resources. I will talk about all 3 and get straight to the point. If you're interested in more videos, you can subscribe to my YouTube channel and click the bell icon. You can also follow me on Twitter, connect with me on LinkedIn and Facebook. I will also place the transcript and presentation slides on GitHub. In this session, I am going to speak about Selenium 4 components, advantages, mobile automation, and cloud platforms. Starting with the components, Selenium has moved from 3 to 4 because of the W3C WebDriver protocol. This is an example of Selenium 3, which includes the JSON wire protocol. The objective of JSON wire protocol was to transfer information from the client to the server. That information was processed over HTTP by sending HTTP requests and receiving HTTP responses. With Selenium 4, the JSON wire protocol has been removed from the new architecture. Now there is direct communication between the browser drivers and Selenium client WebDriver language bindings. The first component has 2 parts combined into one. Selenium client is a separate part and WebDriver language bindings is a different part. Selenium is an API that have commands for automating our browser. WebDriver has only one job, and that job is to talk to the browser through a driver. Each language have their own bindings. Bindings mean the same commands written for Java is also written for C#, Python, Ruby, and JavaScript. You may have noticed that Selenium added support for W3C protocol starting at version 3.8. According to Simon Stewart, in this Selenium 4 webinar with BrowserStack, he mentioned the versions of Selenium since 3.8 have spoken to both JSON wire protocol and W3C protocol. After running your test script, look for info detected dialect W3C to see if your Selenium version is speaking to W3C. Both of these screenshots show W3C for Selenium 3.8 and Selenium 4. If not W3C, then it will show OSS, which means open source software. Back to our diagram. We see the second component is browser drivers, and it have two functions. The first function is to receive a request from Selenium client and WebDriver language bindings, then pass that request to the browser. A driver is also known as a proxy, responsible for controlling the browser. The second function is to return a response from the browser back to the Selenium client and WebDriver language bindings. All of the drivers use W3C WebDriver protocol, and most of them are created by the browser vendors. When it comes to the third component, web browsers, this is where all of the Selenium commands are performed. The browser receives a request, performs the request, and sends back a response to the driver. Also notice how Opera is not available as a driver or browser. In reality, they are still available, but I did not add them because the WebDriver implementations are no longer under development, so native support has been removed for Opera and Phantom.js. Remote is another form of communication to the browser. It can happen through the remote WebDriver or Selenium server. The remote WebDriver is a class that implements the WebDriver interface. With Selenium 4, Firefox and Safari Driver continue to extend remote WebDriver. However, Chrome Driver and Edge Driver no longer extend remote WebDriver, but they extend Chromium Driver. In the introduction, I showed how Chromium Driver, Firefox Driver, Internet Explorer Driver, Opera Driver, and Safari Driver all extend remote WebDriver. We see three of the boxes: remote WebDriver, browser drivers, and web browsers are gray because they all run on the same system. The Selenium server is different. It's a way to communicate remotely when talking to the driver, but not on the same system as the driver. That's why Selenium server is a different color. We start the server by using Selenium standalone jar file. After it starts, the server directs our test scripts to remote WebDriver. For W3C WebDriver protocol, the advantages are standards, stability, and actions. W3C stands for Worldwide Consortium, which is an international group of people that create long-term standards for the web. With that first advantage of standards, our test scripts run consistently on each browser. There were times with Selenium 3 that some commands perform offbeat on different browsers. Since Selenium 4 is compliant with W3C WebDriver, there is no more required encoding and decoding of the API request. The second advantage is stability. I believe backward compatibility is the main benefit of stability. Per Simon Stewart, they are fully aware that some people will want to use the old JSON wire protocol. So the Java bindings and the Selenium server would provide mechanism for people to use the old JSON wire protocol. They know we have spent time, we have spent effort, and we have been dedicated to building up our test suite. Therefore, our test suite would remain smooth for Selenium 4. No changes to our test scripts unless an API has been deprecated. Deprecated APIs like the finds by interfaces have been removed from Selenium 4. As a result, the WebDriver APIs are going to continue working like there was never a change to Selenium. The updated action API is the third advantage. With this API, we can handle the keyboard and mouse events like double-clicking an element. It's an advantage because Selenium 4 offers ways to perform more than one action at the same time, like pressing two keys. That's an advantage for UI automation. For mobile automation, Appium is the tool for using mobile applications. We see on Appium's our site, the introduction shows native, mobile web, and hybrid applications on iOS mobile, Android mobile, and Windows desktop platforms. The Appium client library have implemented elements of the W3C protocol already, I think since version 1.9. Also, cloud platforms such as Sauce Labs and BrowserStack support W3C WebDriver. However, the format of their capabilities will change. You can go to their site to see what capabilities need to be updated. Here's the page for BrowserStack with the introduction section, talk about why changes are being made, what does it mean to me, updating the Selenium tests, and example section that shows how capabilities are passed with the W3C WebDriver protocol. Sauce Labs have a page that shows W3C capabilities, support with these sections. What you will know, verifying capabilities, W3C WebDriver compliant, instantiating WebDriver, and common test scripts configuration errors to avoid. That's it for W3C WebDriver protocol. Don't forget to connect and subscribe. And next, I will demo the relative locators, which locate elements based on the relationship to another element. Thank you for watching, and I'll see you in the next video. Selenium 4 provides 5 relative locators to find an element or elements located above, below, near, to the left of, and to right of another element. In this session, we will use Test Project's website. It's a free end-to-end test automation platform for web, mobile, and API. If you're interested in more videos, you can subscribe to my YouTube channel and click the bell icon. Also, connect with me on LinkedIn, Facebook, and follow me on Twitter. Lately, I have been slow creating my transcripts, but I will make sure to place them on GitHub. Okay, let's go ahead and get straight to the point. Relative locators were formerly called friendly locators. The testng configuration methods, before method and after method, are pre-written. Before method will set up our test, and after method will tear down our test. Our test script is test relative locator below. It will find the sign in button, then click the forgot password link below the sign in button. Let's inspect the sign in button. And we see the value for ID is TP-sign-in. Inspect the forgot password link. And we see the value for the tag name is A. A is for hyperlink. That's all we need to click the forgot password link. There are two ways to write a relative locator. We start by writing driver dot find element relative locator with tag name. And the other way is to bypass writing relative locator and start by using with tag name. Import with tag name. However, there's a difference with the import statements. The import statement with tag name without writing relative locator, we import the package with static. If you want to use the other way with relative locator dot with tag name, it's the other package without static. By default, Eclipse does not import the static package. The tag name for forgot password is A, so we write A dot. Here's a list of our relative locators. I want you to notice something. Each locator is overloaded with more than one option. Above has a by locator parameter and a WebElement elements parameter. The same with below. By locator, WebElement element. Near is the only locator with 4 options. By locator, WebElement element, by locator int at most distance in pixels, and WebElement element int at most distance in pixels. To left of has a by locator and WebElement element. The same with to right of, by locator and WebElement. Right now, we are trying to find the forgot password link, which has a tag name of A and located below the sign in button. So we select below with the by locator parameter. We write the locator for the sign in button by dot ID. The value by in lowercase, the value is TP hyphen sign hyphen in. And let me correct this because it is a class. Bingo. There we go. Now, we can also do one more thing after entering the value for ID. When it comes to a link, forgot password, next is to click the password link. If you wanted to, you can also use WebElement by writing WebElement sign in button, driver.find element by dot ID, and the value will be the same we entered for this statement right here, TP hyphen sign hyphen in. Next, we pass in sign in button, replace it, and that's it. Either way is okay. Now we have the forgot password link and we're clicking the password link. Next, let's go ahead and see if we actually land on the next page. So what we're going to do is go back to the AUT and we're going to click the forgot password link. And to verify that we landed on the forgot password, we're going to inspect reset password. And we see that it has an ID value of TP title. Now, if we wanted to, we can also use an assert statement, but I want to make sure that a statement is printed to the console. Relative locators are good for dynamic elements. A dynamic element are elements that have an attribute value like TP title that changes every time. But in this case, the value is not dynamic, but it's good for dynamic values because if the value changes and the tag name remains the same, that's a good reason to use relative locators. So we have the value and we're going to place it in a string and we're going to call it string title equals driver dot find element by ID value TP hyphen title. Then we're going to get the text and we're going to print the value title and we're going to append it. That's it. Let's run. Receive pass. Now let's check and see if our bingo title equals reset password. That's it for relative locators. We click the forgot password link below the sign in button. And I see you in the next session. Thank you for watching.
Books available in paperback, ebook, and PDF. All Part 1 ebooks and PDF documents are free. Programming books for UFT. Programming books for Java. Here's a Selenium automation book. And TestNG. Subscribe to get notifications of future videos. Don't forget to like, comment, and share.
In this session, we will look at the benefits of using more than one relative locator. I mentioned in the previous session that relative locators are good for dynamic elements. Here's an example of a dynamic element that I covered in my XPath video 87 talking about why we should never copy XPath values. There are two ID values. On the left, the value ends with 37, and on the right, the value ends with 49. In this screenshot, the arrow is pointing to the most recent ID value that ends with 49. The value changed, but the tag name remained at P for paragraph. We can include relative locators to the other locators such as XPath and CSS selectors for finding dynamic values. For this session, let's use the same sign-in page as the previous session, but this time get the text of remember me, which is above the sign in button and to the right of the checkbox. Let's inspect the checkbox. And the ID value is remember me. We also need the tag name of the remember me verbiage. So let's inspect it, and the tag name is span. We're going back to IntelliJ, and I need to copy the element for the sign in button and paste it in our new test script. We also need to go ahead and get the value for the remember me checkbox. So I'm going to write WebElement remember me check box equals driver dot find element by ID, and the value was remember me. Now let's find the remember me text by writing WebElement remember me text equal to driver.findElement, and since we are going to use a relative locator, we add with tag name. The value of the tag name was span. Add the dot, and the verbiage was located above the sign in button. Let's go ahead and print the verbiage by writing S out text equal to remember me text. Then we're going to get the text using a Selenium method. Let's run. We see text is blank. Why is it blank? It's blank because the checkbox and text are both located above the sign in button. Our test script found the checkbox. Inspect the checkbox again. And we see it also has a span tag, just like the remember me text. The checkbox was selected for the relative locator because it's the first span tag. Recall that findElement finds the first web element, so that's why checkbox was selected. In this scenario, we need to use multiple relative locators because it's more accurate than only using one relative locator. Remove the semicolon and add the dot, and the text was located above the sign in button and to the right of the remember me checkbox. Now let's run again and see what happens. Now, text has a value equal to remember me and it passed. Next, let's find a list of web elements. Let's get the URL for our next test script. I'm going to copy https add-ons testproject.io and I'm going to paste it. And this here will take us to the add-ons page. On this add-ons page, we're going to get the names of each platform. If I inspect each icon, the tag name is IMG, and the names are located in alt attribute. We see platform web. I'm going to inspect the next icon, and it shows platform Android. The third icon is platform iOS. They are located to the right of this text box. Inspect this text box, and the value for ID is Q. To find a list of elements using a relative locator, we start by writing list web element, and the name will be all platforms equal to driver dot find elements. Find elements with an S finds all of the elements with tag name with the value of img. To the right of the text box is ID value Q. Here's the logic. We must loop through each image, then print the name. So I'm going to write a for loop for each loop, which is an enhanced loop. And I'm going to write WebElement platform. And the name is all platforms. That's it. Now let's go ahead and print S out. Platform dot get attribute. Not get text, but get attribute. There it is. And inside the quotation, I'm going to write ALT, which is the attribute. Remember, the names were located in the alt attribute, so that's why I wrote get attribute and not get text. I created a video that explains the difference between get attribute and get text. If you want to check it out, you can go to video, I'll put it in the description. I'm not sure exactly the number, but let's go ahead and run. Bingo, we see all of the platform names: Platform Web, Platform Android, and Platform iOS, and it passed. That's it for using more than one relative locator to find a web element, and how to use a relative locator to find a list of web elements. I have more videos on the way. You can like, subscribe, and click the bell icon. Plus, connect with me on LinkedIn, Twitter, and Facebook. And I'll see you in the next video. Thank you for watching. Selenium 4 allows us to open a new window and a new tab in the same session at the same time. After opening the window or tab, we have the ability to work in it without creating a new driver. In this video, we're going to look at the concept of opening a new window and a new tab. With previous versions of Selenium, we could use the robot class to simulate the keyboard and open a new tab by pressing Ctrl-T, then switching focus to the tab after getting the window handle. Now we can perform those same steps with Selenium 4 using one line of code. We can use it for a window or tab. Driver.switch2.new window, window type window or tab get URL. Notice window and tab are written in green. Driver is used to control the browser. Switch to is a method that sends commands to a window. It switches focus between the windows. New window is a method that creates a new window or tab, then automatically switching focus to that new window or tab. Window type is an enum. Enum is short for enumeration, which is a list of constants that define a new data type. In this case, the constants are window and tab that instructs our program to open a new window or new tab. Window is the parameter for creating a new window. Tab is also a parameter, but it's used for creating a new tab. Last is the getURL method, which loads a new page in our browser. For our test script, we have a setup method. To load an automation practice website, then get the title. I commented out the teardown method because I want the page to stay open after executing our test script. Let's start the test by writing @test public void test new window concept driver dot switch to dot new window type dot, and we see tab and window. Let me import our test annotation from testng. Hover the new window method, and the description states creates a new browser window and switches focus to that window for future commands of this driver to the new window. You know what? Let me read that again. Creates a new browser window and switches the focus for future commands of this driver to the new window. In shorter words, it will open a new window, then switch focus to that window. We also see the parameters are type hint, which is a type of new browser window to be created. The type hint will be window or tab. Returns. This driver focuses on the given window. When it says window, it's referring to window or tab. That's why I was able to write window type.tab. One more point. Do you see how the return type is WebDriver? If we choose to, we can assign this statement to WebDriver with any name like new page. Let's run. We have two tabs, and a blank tab is open with automatic focus in the new tab. The same outcome happens with the new window. Change tab to window, then run. And that's one of the reasons why I commented out the teardown method, because Selenium executes so fast, and I want the tab to stay open so we can look at it, and the window to stay open. A blank page is open in a new window. For our test script, after the blank page, we're going to open the Contact Us page. Let me grab this URL and load a new page by writing new page dot get. At this point, and in the slide, I mentioned get, but we can also use the navigate method to open a new page. And I'm going to paste the Contact Us page. Also print the page title, sysout title, driver.get title. Let's run. Bingo. Let's go back to our IDE. Both titles are displayed in the console, My Store and Contact Us, My Store. Next, I will show you how to open, switch, work in the new tab, then switch back focus to the parent tab. And thanks for watching, and I'll see you in the next video. Our steps for opening, switching, working, and switching back to the parent is to access this home page of this automation practice site. Then open the sign in page in the new tab. On the sign in page, we will work in this tab by entering an email address and clicking the create account button. We are not going to perform any actions to create an account, but switch back to the parent tab and start shopping. Let's start our test by writing at test public void test open switch work in new tab. Then add some comments as our steps. We're going to add open and switch to new window tab. Next is to work in the new window tab. Then get the window ID handles. Last is to switch back to the parent window tab and work in the first window tab. Cool. First step, we're going to open and switch to the new window tab. We write driver dot switch to dot new window. Type hint is window type dot tab dot get and paste the URL. Since this URL is so long, we can place the get method on the next line by hitting enter after dot. You can also end the previous line with a semicolon and start the next line with driver.get. Either way will work. However, I'm going to remove the semicolon and driver. It's still long, but let's also print the title, sysout title, plus the driver.get title method. Now, let's work in the new tab. Go back to the AUT and inspect both elements. Email address has email underscore create as the ID value, and the button has submit create as the ID value. Capital S, capital S, and capital C. Okay, for the email, we write driver.find element by ID. The value is email underscore create. And the keys we will ascend is automation 34 at selenium4.com. Then driver.find elements by ID. The value for the button is submit create, and we click for the button. Bingo. There it is. Okay, we are finished working in the new tab. At this point, you can decide to close the new tab or leave it open. If you close the tab, make sure to use driver.close and not driver.quit. Driver.close will close the new window, but driver.quit will quit the driver and close both windows. I think it's video 18 that will show you the difference between close and quit. Now, let's get the window handles of each tab. The window handle is an alphanumeric ID assigned to each window or each tab. Set string all windows equal driver.getWindow. And we see two methods. The getWindowHandle method returns one window ID handle. GetWindowHandles method returns a set of window handles that can be used to iterate over all open windows. Select this method. The next method is to return an iterator for the collection of both window IDs. String iterate equals all windows dot iterator. We need a way to iterate the collection of elements, and next is a method for returning an element. String parent first window is the parent tab, and it's the first element of the iteration, in the iteration. Iterate dot is the next element, which is string child second window, and that window is the new tab that we're going to open. For this example, that's all we need to get the window IDs and iterate the IDs. You can also loop through the windows. The last step is to switch back to the parent. Let's write driver.switch2.window. Let me explain this part. Do you see window and a new window? Both the methods involve switching focus to a window, but the window method deals with handling a window, and the new window method opens a window. The window method receives a name or handle. We get the name or handle information after using the getWindowHandle method or getWindowHandles method. There's a difference between handling the window and opening the window. I created video 71 that provide more details on how to handle the windows. In that video, I use all three methods: getWindowHandle method, getWindowHandles method, and driver.switch2window. Right now, we are opening a new window, then working in the window, which is a benefit because it allows us to multitask in a different tab. Before Selenium 4, we could not multitask, but had to perform a different task in the same tab. Select window, then pass in parent first window, because we're switching back to the parent tab. Let's go to the AUT and search. Inspect the search box. We see ID is search underscore query underscore top, and the search icon has no ID value, but a value of submit underscore search for name. Let's enter some data by writing driver.findElement by ID, and the ID value was search underscore query underscore top, and we're going to send the keys as faded shirt. Look for a faded shirt and click the search icon by writing driver.findElement by name is the locator this time, and the value for name was submit underscore search, and we're going to click the search icon button. Let's also print the title by writing title driver.get title. There it is. And let's run. The reason why I like to print the title, because I want to make sure that we can see the page title for each page in the console. So we're going to see when it finishes running what the console shows. We see both tabs had some kind of information. The parent tab had faded shirt in the search box. And the new tab is ready to create an account with our email address already populated. Let's see if the console shows each page title. Bingo. We see all three titles: My Store, Log in My Store, and Search My Store. Bingo. Thanks for watching. If you liked the video, click the thumbs up button, subscribe, and click the bell icon. You can also connect with me on LinkedIn and Facebook, plus follow me on Twitter. When I have more time, I will also place the code and documents on GitHub. And I'll see you in the next video. In this session, let's look at a new Selenium 4 feature to minimize the browser. We can always minimize the browser, but this feature is built into Selenium. The other ways were to set the position of a window and to use the robot class. Personally, I like to watch the automation of our test scripts in the browser, but if you have a requirement for minimizing the browser, then this will help you out. Also, if you're interested in more videos, you can subscribe to my YouTube channel and click the bell icon. Also follow me on Twitter, connect with me on LinkedIn and Facebook. We are going to use this orange HRM site by entering the username, password, and clicking the button. Username is admin. Password is admin123. Inspect the username. It shows txt username as the value for ID. Inspect the password. It shows txt password as the value for ID. Now let's inspect the button. It shows btn login as the value for ID. To use the robot class, we select Alt space, and do you see minimize? That's how we minimize using the robot class. Oh, by the way, this minimize feature became available in Selenium 4 Alpha 5. So far, this test script is set up to load Chrome driver and to load the AUT. Now we enter the at test annotation. Public void minimize using new feature. Import the test annotation from test.ng. Now we write driver manage window. Normally we select maximize, but here's minimize. Enter the username by writing driver.findElement by ID. The value for ID will be txt username. And the keys we send will be admin. Enter the password by writing driver.findElement by ID. The value for password is txt password. And the keys will be send, keys will be admin123. Next is to click the button by writing driver.findElement by ID. And the button password is btn login. and we click the button. Let's run. It passed in 3.922 seconds. That's pretty fast. I've seen it run faster with minimize and also seen it run faster with maximize. Let's run it with maximize and see what happens. At test, public, void, maximize. My typing, maximize window. Copy this code from minimize and paste it. And change minimize to maximize. Let me do that one more time. How about just write it? driver.manage.window.maximize and run. Maximize executed in 3.556 seconds. Now, let's minimize the browser by setting the position and using the robot class. Starting with the set position, we write at test, public, void, minimize using set position. Driver.manage.window.set position. Now we write new point. At this time, we write -2000 for the X coordinate and 0 for the Y coordinate. Import point from the Selenium package. Point is a Selenium class that's a copy of Java's AWT point package. It removes the dependency of AWT. Copy and paste the same code. Now we finish with the set position test. Now is a robot class. At test, public, void. Minimize using robot class. Robot equals new robot, which is the constructor. Import robot from java.awt, then add the throws declaration. Yes. Select AWT exception, but we can also select exception. Give us more room. First, we press the Alt key by entering robot dot key press key event dot vk underscore ALT. Bingo. Now we press the space key by entering robot.key press key event dot vk underscore space. Next is the end key. So now we write robot.key press key event dot vk underscore n. So now we have to release the keys. We press the keys here. Now we have to release the keys. So I'm going to copy these three statements and I'm going to change key press to key release. And that's it. So there we go. Press to release. For the last time, change press to release. Now, let's run all 4 of the methods. Minimize robot class, set position, maximize window, and minimize using new feature. Run all. We see the time for each test script, and it looks like robot class was the fastest. This time it showed maximize second, minimize third, and minimize using set position as the last for speed. That's it for minimizing the browser using new feature for Selenium. Thanks for watching, and I'll see you in the next session. In our automation program, there are scenarios that requires us to get the position and or dimension of a web element. The positions are X and Y coordinates, while the dimensions are width and height. Selenium 4 has the getRect method that allows us to get both positions and dimensions. X comes before Y and width comes before height. The X coordinate is measured horizontally starting from the left to the right. The Y coordinate is measured vertically starting from the top to the bottom. Width and height are ways to measure the size of an element. Notice there are 2 differences between Selenium and how we normally measure in math. On a web page, the length is not available as a dimension, and Y is not measured starting from the bottom. With Selenium 3, we have getLocation and getSize. The getLocation method returns X and it returns Y, while the getSize method is used to fetch the width and height. With Selenium 4, the new getRect method is a combination that gets the X coordinate, Y coordinate, width, and height. In this video, I am going to show you all 3 methods: getRect, getLocation, and getSize. Then compare getRect to see if it returns the same values as getLocation and getSize. If you're interested in programming and automation videos, then subscribe to my YouTube channel and click the bell icon. Also, connect with me on LinkedIn, Facebook, and follow me on Twitter. The code, presentation, and transcript document will get placed on GitHub. We're going to use this orange HRM logo as our web element. When I inspect the logo, we see IMG as the tag name and SRC as the attribute, but no ID attribute. However, the parent has an ID value of div logo. There are different ways to get this value. This time, I'm going to use CSS. Control F to bring up this find by string selector or XPath. Then write hashtag. Then div logo for ID. Space, angle bracket IMG. Bingo. Copy this value. Also, let's look at the size and location. Go to Properties. Select IMG. And we see height as 81. Width is 417. X is 423. And Y is 75. Let's go to our test script and start with the get getRect method to make sure the measurements are the same. At test public void get position dimension. The WebElement my typing is logo orange HRM equal driver dot find elements by CSS selector. The value, we're going to paste it. Now that we have the logo orange HRM web element, we can access getRect method. Do you see rectangle? That means the getRect method returns a rectangle. The description shows it returns the location and the size of the rendered element. Since it returns a rectangle, we assign the location and size to rectangle with an object name like rect logo. That's all we need to get the X and Y coordinates plus the width and height. Import the rectangle class from Selenium package. Also import the test annotation from testng. Let's print these values and start with X. Sys out X plus rect logo dot get. And we see get height, get width, get X, and get Y. Select get X. Then perform the same process for each method. Sys out Y. Append rect logo dot get Y. Sys out. Now we're going to get width. Rect logo get width. Last is sys out height. Rect logo get height. Let's run. It's the same values. X is 423, Y is 75, width is 417, height equals 81. Let me hover over this rectangle class, then open the decoration. We see two constructors. The first constructor has 4 int parameters: X, Y, height, and width. However, the second constructor has a point parameter and a dimension. With Selenium 3, we had to use the point and dimension classes to help us get the location and the size. Both classes are still available in Selenium 3. Let's compare getRect with getLocation and getSize. Go back to our test script and erase these print statements. Then start from scratch. For location, we write logo orange HRM dot get location. And we see point as the return type. After selecting get location, we assign point with any name like point logo. Import the point class from Selenium. Look at this. We write point logo dot, and we see X, Y, get X, and get Y. But notice we do not have width and height. Width and height are not available because it's part of the points class. For width and height, we write WebElement logo on HRM dot get size. This time we see dimension as the return type. So we select get size, then assign it to dimension with dim logo as the object. Import dimension from the Selenium class. Now dim logo have height, width, get height, and get width. Let's print the values to verify we get the same values. Let's add some headers. Tab Selenium 3 and write Selenium 4. These are going to be the headers. Now let's add some hyphens. I guess that'd be enough maybe. All of the methods, all of them came from Selenium 4, but I put Selenium 3 in the print statement. Selenium 3 would represent the old way of getting the location and getting the size. Now let's add some print statements to get X, Y, width, and height. Start with X. Put in 2 tabs, and we're gonna use point logo to get X. Now let's put in 2 more tabs, and we're going to get Selenium 4 by using rect logo get X. Now we're going to do sys out for Y. 2 tabs. I should have copied point logo dot get Y. Let's add some more tabs for the section for Selenium 4. Rect logo will also get Y. Sys out, and now we get width. We're going to put in 2 more tabs. And this time we use dim logo to get the width. 2 tabs. And we're going to use rect logo to get the width. Bingo. Now this time I'm going to copy and not write all of that for this statement. And width change to height. And this time I'm going to take get width and make it get height. And the same for the Selenium 4 get rect. And let's run. We see the same exact values for X, Y, width, and height. The benefits of Selenium 4 rectangle class is it has all of the methods. That's it, and thank you for watching, and I'll see you in the next session.
Books available in paperback, ebook, and PDF. All Part 1 ebooks and PDF documents are free. Programming books for UFT. Programming books for Java. Here's a Selenium automation book. And TestNG. Subscribe to get notifications of future videos. Don't forget to like, comment, and share.
In this session, we're going to take a screenshot of a WebElement. Until now, Selenium already had a feature to take a screenshot of a page, but not to take a screenshot of a WebElement. Before Selenium 4, we had to use an API called AShot to take a screenshot of a web element. However, in this session, I am going to demo how to take a screenshot of one web element and a page section that includes more than one web element. If you're interested in more videos, you can subscribe to my YouTube channel, then click the bell icon. Follow me on Twitter and connect with me on LinkedIn and Facebook. Also, I'm going to place the transcript and code on GitHub. We are going to use this orange HRM site. I will take a screenshot of this logo for one web element. Do you see how this part of the page has more than one web element? We see username, password, login button, and the forgot password link, plus this orange image. I am going to take a screenshot of this entire section using Selenium 4. Let's start with the logo and inspect. Then find the value by writing hashtag div logo. This is the ID value for the parent. Space, angle bracket, IMG is the tag name for the logo. Let's start by taking a screenshot of the web element logo. We have our test set up to load Chrome and the AUT. Now, let's take a screenshot of the logo by writing @test public void take web element screenshot. Let's find the web element by writing web element logo orange HRM equal driver dot find element by CSS selector. And the value was hashtag div logo space angle bracket IMG. Import the web element and the test annotation from testng. Now that we have the logo from HRM, orange HRM, we get the screenshot as output type dot file. The get screenshot as method captured the screenshot and store it in the specified location. Notice the return type is file. Let's hover the output type, and it defines the output type for a screenshot. File is used to obtain the screenshot into a temporary file. Therefore, we'll assign the screenshot to a file and name it source. Import. Now we need a file for our destination. Equals new file called orange HRM logo. The extension would be PNG. We have our source file and destination file. A class called file utils has a method to copy the file. The description shows that it copies a file to a new location. So for the source file, we're gonna have source. And for the destination file, we're gonna have our destination. Depending on how your Selenium 4 is set up, you may have to download the Apache Commons IO jar from Maven's repository to get this file utils class, then import the jar. It's also a dependency hierarchy for WebDriver Manager. Last step is to add the throws declaration for IO exception. That's it. Let's run. Bingo. we see the screenshot in our project. I set up Eclipse to auto refresh, so I did not have to manually right-click the project and select L5. I'd have to do that. Video 72 will show you how to refresh your project automatically. I'm going to right-click, select Open. And here's the logo WebElement screenshot. Next, it will take a screenshot of a page section. In a section, there are multiple web elements, so we need to find the parent tag of those web elements. Inspect this section, and we see the parent tag has an ID value of div login image. On this page, another section is the social medias icon that also can be used to take a screenshot of multiple web elements. All we need to find is the parent tag, and Selenium will take a screenshot of all 4 of these social media icons. In this example, social icons is the parent tag. Go back to our IDE and write our test for the page section. So I'm going to write @test public void take page section screenshot. The page section is a web element. So we write web element page section orange HRM equal driver dot find element by ID. And the value was, I think it was div login image. So next is to store the screenshot in a file. Therefore, we write file source equals. What is the source? The source is page section orange HRM dot get the screenshot as output type dot file. This statement is an abstract representation of the file class and was saved in the screenshot in memory. We need a physical file since this is an abstract representation. Therefore, we copy the source file to the destination. I'm going to use these 2 statements and combine them into one line. So I'm going to write file utils dot copy file. The destination file would contain the name of the new file, but first the source file will be source. Destination, I mentioned it would be the name of the new file, and that name is orange HRM page section. There we go. You can also use JPEG as the file type, but I like to use PNG. This statement will convert the abstract source file into a physical .png file so we can view the screenshot. Add the throws declaration and run. We see the page section screenshot. Let's open. And all of the web elements are located in the screenshot. That's it, and thanks for watching, and I will see you in the next session. In this session, I am going to take a full page screenshot using Selenium 4. Right now, it's only available for Firefox. There's a difference between the full page screenshot and the existing screenshot feature. The existing screenshot feature takes a screenshot of the page that we can see in our web page. However, the full page screenshot takes a screenshot of the entire page, whether we can see it or not. I create videos every week, and if you're interested in more videos, feel free to connect with me on LinkedIn and Facebook. You can also follow me on Twitter and GitHub. If you're on YouTube, you can subscribe to my YouTube channel and click the bell icon. I'll make sure to place the transcript and code on GitHub. Our AUT is going to be Amazon. On this page, we see it's very long and has a lot of products. Scroll, and we see more and more. Now, let's go to our code. We have a setup method for Amazon using Firefox driver and a teardown method to quit the driver. Start by writing add test, public void with the method name of take full page screenshot. The first step is to capture the screenshot using Firefox driver. The plan is to use driver, which is a variable of type WebDriver. We're going to use driver to call a method that's only available to Firefox driver, and that method is get full page screenshot. Output type is file. Let's save the file and name it source. Import the test annotation from testng and the file. If you want, feel free to separate this statement into two statements. However, I'm going to continue and get straight to the point. Also, with the next statement, we can separate it into two separate statements, but I would write one line. Let's handle the file with file handler dot copy. From is source. To is the destination, which is a new file named Amazon full page screenshot .png. That's all we write to capture the full page. Add a throw declaration and select IO exception. Let me also capture a screenshot, but not the full page. It won't take long. I want to show you the difference between full page screenshot and the existing screenshot feature. Add test, public void, take page screenshot. It's very similar to the full page screenshot, but I would write take screenshot and not Firefox driver. All right, file source equal. Then we cast takes screenshot driver. Import takes screenshot from Selenium package and dot screenshot. Let me start over because I want to show you something right quick. Dot screenshot. And notice we only see get screenshot as, but we do not see get full page screenshot as. That's how we know get full page screenshot as is only available for the Firefox driver. Select get screenshot as. Output type is file. Next is file control space. We have the option of using file handler or file utils. File handler is a class from Selenium, and file utils is a class from Apache.commons. I'm going to use file utils This time, since I used file handler in the previous test script, and select copy file, source, and once again, destination file is new file. And the name would be Amazon, just say screenshot, .png. Throws declaration, and we're going to select IO exception. I'm going to save it, and this time I'm going to run all and not just an individual test script. We see both screenshots. We see both screenshots, Amazon full page screenshot and Amazon screenshot. And like in the previous video, I mentioned that I set it up where it refreshed automatically, and I do not have to click F5 or refresh the page. Let's open both screenshots. Right click, hit open. This here is the screenshot, which shows what we only saw in the web page, and it stops around this point. Select the other screenshot, and we keep on scrolling, and the full page screenshot took a screenshot of the complete page from top to bottom, but not including the tab and address bar. But the take a normal screenshot capture only what we see in the browser page. That's it, and thank you for watching, and I'll see you in the next session. Hello and welcome. In this session, I will talk about CDP, which is an acronym for Chrome Debugging Protocol. It's a new Selenium 4 API feature that's designed for debuggers. All browsers built on the Chromium platform has an option for developer tools. Therefore, another name for CDP can be called Chrome DevTools Protocol. If I go to Chrome, then click this vertical ellipsis, navigate to more tools, and at this point we see developer tools. Dev tools is short for developer tools. Click and we see a few tabs. Elements is the most popular tab for automation, but we also have console, sources, network, performance, memory, application, and security. It's the same panel if I right click a page and then click inspect. Microsoft Edge also has the same tabs after accessing developer tools. We click this ellipsis, more tools, and here's developer tools. Selenium 4 provides a way for us to take advantage of Chrome and Microsoft Edge's debugging protocol. Let's look behind the scenes at the classes and methods. Starting with the Chromium driver. We see the Chromium driver class. Open the type hierarchy. Notice the Chrome driver and Edge driver classes are both under the Chromium driver class. That's because Chromium driver is the parent. However, Chromium driver is a child to the parent remote web driver. In a nutshell, Edge driver extends Chromium driver, and Chrome driver extends Chromium driver, but Chromium driver extends remote web driver. There's a lot of methods in the Chromium driver class, but two methods allows us to control developer tools in Chrome and Microsoft Edge. Those two methods are execute CDP command and get dev tools. The execute CDP command allows us to directly execute a Chrome dev tools protocol by passing in a parameter for that command. Get dev tools is a method that returns dev tools. DevTools is a class that has methods to handle developer options. We see close, send, add listener. Know what? Let me go back to the Project Explorer and look at the methods for DevTools. Here are the methods within DevTools. We see add listener, clear listener, close, create session if there is not one, get CDP session, and send. We see a lot of methods for DevTools. That's because we can do a lot of things with CDP. I'm going to show you how to view the console logs when it comes to CDP. Also how to mock a geolocation and enable the network speed. Thanks for watching, and I will see you in the next session, starting with view console logs. If you're interested in more videos, feel free to subscribe to my YouTube channel and click the bell icon. Also follow me on Twitter, connect with me on LinkedIn and Facebook, and I'll see you again in the next session. And thank you. There are two objectives for viewing a browser's control panel. First is to execute JavaScript. Second is to view messages logged by the browser or logged by the developer. In this session, our focus will be to view messages logged by the browser. Most of the times, we view the console logs to get details about an error. With those details, we can identify the root cause of the problem. Our AUT is this Lego page, and Control-Shift-I is a shortcut to the Developer Tools panel. In the Console tab, we already have some logs because the page has already been loaded. We can clear the logs, reload the page, then watch the logs show back up. DevTools failed to load source map and HTTP error status code 404. The Developer Tools class in Selenium 4 provides a way to listen to these logs, which has 4 log levels: verbose, info, warning, and errors. Verbose is not checked for default. Therefore, the messages will not be wordy. It won't have many words in the message. Info means the logs will have important information about an event. Warnings indicate a strange condition might cause a problem with operations. Errors let us know a condition is likely to cause a problem with operations. Now, for our test script, Chrome driver is set up and the window is maximized. Start by writing @test public void view console logs. Let's add some steps, but write them as comments. First, we get the dev tools and create a session. Let me correct this right quick. I don't want to misspell it. Then send a command to enable the logs. Next, we add a listener for the logs. Finally, we load the AUT. To get the dev tools, we must cast the driver if WebDriver is our type. We cannot directly write driver.getDevTools. Notice getDevTools is not available. We have to cast the driver by writing Chrome driver, driver.getDevTools. If you want to directly write driver.getDevTools, we must change the type to Chrome driver. Now I'm going to start over and write driver.getDevTools. Do you see how getDevTools return DevTools? That's an indicator this statement must be assigned to DevTools with an object reference of any name, but I'm going to write DevTools. Now we have access to all of the methods I mentioned in the introduction. Before we perform any more steps, we must take control of the Developer Tools panel in the browser by creating a session. DevTools.createSession. The purpose of this statement is to start a session in the Chrome browser. Next is to enable the logs in the console. DevTools.send. Send is a method that has built-in commands and accepts command as a parameter. It allows us to interact with the developer tools. Log.enable allows us to listen to the logs in the next part. But for here, we see log.enable is one of those commands for the send command, for the send method. Log serves as a representation or model for the CDP command. Now that we have the logs enabled, this is the part where we go and listen for the logs by writing devtools.addListener. Once again, we write log, but this time it's an event for entry added. Log entry and a lambda expression. To use this lambda expression, you must have Java 1.8 or higher. Let's print, let's print some of them log entries. And I'm going to start by writing S out for log entry dot as Selenium log entry. This is where I notice a difference between Selenium 4 Alpha 1 and the current version. I changed my pom.xml file to use the version for Alpha 1. Alpha 1 has as Selenium log entry for a method. In this screenshot, we see Alpha 6 does not have as Selenium log entry for a method. Alpha 6 is not the most recent version. However, Alpha 6 and the most recent version added more methods, although as Selenium log entry is missing. So they don't have as Selenium log entry as a method, but it added more methods. Alpha 1 does not have methods getArgs, getLineNumber, getNetworkRequestID, getStackTrace, getURL, and getWorkerID. Go back to my IDE, and here's my pom.xml file that shows Alpha 1 for Selenium 4. I'm going to add some hyphens. And then add some more log entries. Maybe 1, 2, 3, 4, 5, 6, 7, 8, maybe 10 or so hyphens. And the log entry I'm going to add now is source. Log entry dot get the source. I'm going to copy this and also get the source for, get it for level. There it is. And change source to level. Let's add maybe 2 more log entries. Change level to text and change get level to get text. Change level to timestamp and change get level to get timestamp. Okay, last but not least, we're going to load the AUT to view the console logs. Driver.get. And I think the URL is https://www.lego.com/404. Let's run. It passed. In the console, we see some of the same information because that method adds Selenium log entry combine different log entries. And we also printed the individual entry. For example, it has source as network, level equal to error, text equal to failed to load resource, and the timestamp. That's it for capturing the logs using Selenium 4 CDP, and I'll see you in the next session. If you're interested in more videos, feel free to subscribe to my YouTube channel and click the bell icon. Also, follow me on Twitter, connect with me on LinkedIn and Facebook. The transcript and code will get placed on GitHub, and I'll see you in the next session. Thank you. In this session, I will show you how to mark a geolocation using Selenium 4 CDP. Mark means imitate, and geolocation refers to the geographical location of a device connected to the internet. The device can be anything, a phone, laptop, or even a watch. We use geolocation for events like finding the location of a place. On Selenium site, we see Chrome Dev Tools, emulate geolocation, description, and code to emulate the geolocation. The description, it says some applications have different features and functionalities across different locations, but with the help of dev tools, we can easily emulate them. Depending on the application, we can see different information because the application is in a different location. With this help of Chrome DevTools protocol, the application can have the same information after marking the geolocation. We can mark, well, this site says emulate. We can emulate the geolocation by making our browser be in the same location. As a result, the application will have the same features and functionalities we are trying to test. For example, I live in Texas, but on my project, I work with people who live in India. If our application showed different information in India, then I would change my location to be in India. For this test, I am going to make my browser be located in the capital of India. In this pom.xml file, I changed my Selenium 4 version to Alpha 7. From scratch, I'm going to write add test, public void, mark geo location. Set up our browser by writing WebDriver manager .chrome driver .setup. My typing not going good so far. Hope it get better. Chrome driver is the type, and driver will be the object. Chrome driver will be the browser, and we're going to maximize it by writing driver.manage.window.maximize. There it is. Driver.exec. Notice how execute CDP command has string command name and map for the parameters. In the sample code, the command is emulation.set geolocation override and coordinates for the map. The coordinates are latitude, longitude, and accuracy. For more information, we can go to GitHub. The URL is chromedevtools.github.io/devtools protocol. Search for Geo. And we see emulation.setGeolocation override with a description that says overrides the geolocation, position, and error, or error. We see all three parameters: latitude, longitude, and accuracy. I'm going to set my geolocation to be at New Delhi. And we see the coordinates are 28.6139 for latitude and 77.2090 for longitude. Latitude is always first. We see N for latitude because the direction is north or south. E for longitude because direction is east or west. Our application under test is where am I right now? I guess this site is accurate. The location is half a mile from my house. We see TX for Texas. Now let's go ahead and complete our script. First parameter is string command name. We saw emulation dot set geolocation override. Hope I spelled it right. The second parameter was a map. And Selenium site, I'm gonna copy this code and just paste it to our code. And change latitude to 28.6139. And I think the longitude was 77.2090. Leave accuracy at 1. Now I can pass in coordinates. Bingo. Last step is to load the application under test, and that is driver.get. String name is, let me go back and just copy it because I do not remember the string name, the URL. Bingo. And paste it. Now, let's run. The test passed, and that's it. We see New Delhi for location. We see latitude and longitude. Also, here's the map. That's it. And thanks for watching, and I'll see you in the next session when I enable the network by simulating the speed of the network. If you're interested in more videos, feel free to subscribe to my YouTube channel and click the bell icon. Also follow me on Twitter, connect with me on LinkedIn and Facebook, and I'll make sure to place the code and transcript on GitHub. The network panel is another way to debug a problem. It has logs to help us troubleshoot the problem. We mostly use the panel for two reasons. One reason is to inspect the network properties of a resource. Another reason is to make sure our resources are downloaded and uploaded as expected. When testing an application, it's easy to forget or not think about a user with a weak connection. Therefore, we are going to automate how to slow down our internet connection. In the network panel, there is no available request. It's empty because we must open the panel before performing an action. That's how we preserve the network traffic data. Refresh the page, and all of the network activity shows up in the network log. Each row in the network log represents a resource. Do you see 69.2 KB transferred? That's the total download size. This network throttle and drop down is how we emulate different connection speeds. We see fast 3G, slow 3G, and offline. In this session, I will automate a 3G connection, but next session, I will take the network offline. Select any preset, and the DevTools display a warning icon beside the network tab. For our test script, I have the setup method for edge driver. Let me also add driver.getDevTools. Assign it to DevTools. Also write DevTools up top. Enable the network to slow down by writing add test public void enable slow network. Start by creating a session. DevTools.create session. Then we send a command to enable the network by writing DevTools.send network.enable. Optional dot empty. Let's write this statement 2 more times. This complete statement makes it possible to deliver network tracking and events to the client. All of the parameters are optional dot empty because they are not required. In fact, the first 2 parameters are experiments. Next is to emulate network conditions. We can go to GitHub for the method and parameters. Search for emulate. At the bottom, we see network.emulate network conditions. It activates emulation of network conditions. The parameters are offline, latency, download throughput, upload throughput, and connection type. Connection type is the only optional parameter. The method we wrote for enabling the network is right here. And we see all 3 parameters are optional. Max total buffer size, max resource buffer size, and max post data size. If I hover the experimental, the tooltip shows this may be changed or removed. For our test script, let's complete it by writing DevTools.send network.emulate network conditions. We want the network to stay online, so we set offline to false. Bingo. Latency is 150. Download throughput is 2500. Upload throughput is 2000. Next is the connection type. So we write optional dots of connection type dot, and we see different options. We have Bluetooth, 2G, 3G, 4G, and somewhere in this IntelliSense we should see Wi-Fi. Let's go ahead and select 3G. And add the semicolon to complete the statement. Okay, let's also compare the time between this slow network and the normal way by loading an application. And you know what? Before we compare, we must load the application for LinkedIn. I got ahead of myself. www.linkedin.com. I think that's it. You know what? Let's also print the page title. Slow driver dot get title. Now let's go ahead and load LinkedIn the normal way. I'm gonna show this also, the code. Add test public void access LinkedIn. And all I'm gonna write is driver dot get title. Get HTTPS colon 3 W's LinkedIn.com. My typing is super bad this time. Access plus driver dot get title. I think this is everything. I think so. Let's go ahead and run. Both tests passed. The console shows access LinkedIn loaded in 2 seconds and 478 milliseconds. Enable slow network took longer to complete. It finished in 50 seconds and 60 milliseconds. Both test scripts show the page title. That's it for slowing down the network to a slower connection. Next, I'm going to show you how to take the network offline. If you're interested in more videos, consider subscribing to my YouTube channel and clicking the bell icon. Also follow me on Twitter, connect with me on LinkedIn and Facebook. The transcript and code will get placed on GitHub. Thanks for watching, and I'll see you in the next session. In this session, we are going to enable the network to be offline. It's very good when an application has functionality to continue working offline. There are many reasons for an application to be offline, such as bad weather, a power outage, or even driving into a dead zone. Here's our application under test. Most of the times I use Chrome, but not this time. For some reason, Chrome does not include the same offline functionality as Microsoft Edge. I'm going to right-click, inspect, and go to the network tab. The network drop-down, throttling has different options. We're going to select offline. Refresh. Yes. And notice the message says you are not connected. And it also shows internet disconnected. A lot of applications stop right here and do not let us continue. However, we can still perform an action while offline. Do you see want to play a game while you wait and this launch game button? Let's inspect this launch game button, and we see the ID value is game-button. Now, at this point, we're going to do the same steps in our automation. In our test, we're going to set the network to be offline, then click this launch game button. It's a surf game. For our test script, I already have Edge driver, dev tools, and the setup method for Edge driver. It's from the last session when we slowed down the network connection using 3G and access LinkedIn. Now let's write at test public void enable offline network. We always begin by creating the session. Dev tools dot create session. This will start a session in the Edge browser. Next is to send a command so we can enable the network. Dev tools dot send network dot enable. The enable method has 3 parameters and all 3 of them are optional. Therefore, we write optional dot empty, comma. And I'm going to write that 2 more times or paste it 2 more times and make sure to add the semicolon. If I hover enable, the description shows enables network tracking. Network events will now be delivered to the client. Those 3 parameters are buffer size, max total buffer size, max resource buffer size, and max post data size. After enabling the network, we are going to send a command to emulate the network conditions. DevTools.send network.emulate network conditions. Hover the method, and this shows activates an emulation of the network conditions using 5 parameters. The 5 parameters are offline, latency, download throughput, upload throughput, and connection type. I don't see it here, but connection type is optional. Now, let's go ahead and continue with our test script by writing the value for offline, and that value will be true. This means, yes, the network will be offline. 10 is the value for latency. Latency is sometimes called lag. It's a delay in communication across the network. 100 for the download throughput. 50 for the upload throughput. Throughput refers to the amount of data that's transferred from the source to the destination. For connection type, we write optional dot of connection type dot. And we see the different G connections, but let's select Wi-Fi. And I gotta make sure to add this semicolon. Now let's add a listener and what we expect. And we write DevTools dot add listener. At this point, I'm going to write some data inside the add listener, some parameters. And that starts with loading failed, comma, loading failed. And we are going to select the example with the lambda expression because there are 2 options. Now we write assert equals. And inside assert equals, we're going to write loading failed. And we're going to select the one that do not have parentheses. Dot get error text. Bingo. Remember when we saw internet disconnected after setting the network to offline, then refreshing the page? That's what we expect. So I'm going to write net 2 colons ERR underscore internet disconnected. And I hope I spelled it right. The last step is to load the page. Since it's offline, let's try to load the page by writing driver.get. The value is https://3w google.com. Next is to catch the possible exception. That exception is WebDriver exception, exe, and click the button by writing driver.yes. Do you see the extra find element by options? We have these options because our type is Edge driver. It's been available to us for a long time, the same with Chrome driver and Firefox driver. However, they're supposed to be deprecated for Selenium 4. I spoke about this in the introduction to Selenium 4, the first video. I'm going to select driver.findElement by ID. The value was game-button dot click. Also, print the page. Print the page by writing offline driver.getTitle. Let's go ahead and add this part here in parentheses or quotation marks that says page did not load. That's it. And let's run. It passed, and we see the game. Now, for our console, let's see what it shows. Enable offline, and we see the console showing offline www.google.com, and the page did not load. Thank you for watching, and I'll see you in the next session. I create videos every week. And if you're interested in videos that I create, feel free to subscribe to my YouTube channel and click the bell icon. Also follow me on Twitter, connect with me on LinkedIn and Facebook, and I will make sure to place the transcript and code on GitHub. And I'll see you later. In this session, our focus will involve loading an untrusted website. Depending on your browser, there will be a different message, but it all comes down to a security issue. It's recommended we do not visit the site. However, there may be a scenario for us to test this type of application. On Firefox, the message says, warning, potential security risk ahead. It's letting us know that an attacker could try to steal our information. Chrome has a similar message about attacker might be trying to steal your information with the heading that says your connection is not private. Edge has the same message as Chrome. Our automation test script will ignore these security warnings and load the page. If I click the advanced button, we see a link that says continue to self-signin.badssl.com unsafe. Click this link and the self-sign.badssl.com site loads without a problem. GitHub has more examples just like this one. We see 5 sites that have subdomains that will generate the same type of warning. For our test script, it's already been set up for Chrome driver and dev tools. The last statement assigns get devs tools to devs tools. Let's start by creating a method with add test public void. Name the method load bad website. Next, we create a session with devtools.create session. Now we are going to send a command to ignore the certificate error. devtools.send security dot security provides access for us to set ignore certificate errors. This statement is similar to clicking the advanced button and the unsafe hyperlink. We pass in a Boolean value of true. True is another way of saying we trust the website, so it will successfully load the page. That's it. Last part is to load the AUT, driver dot get. And I think the website is https://self-signed badssl.com. The key is ignoring the certificate error by passing in true. A negative test case is pass in false, which will not load the untrusted website. Now I'm going to paste the code from what we just used to ignore and change true to false. Change the name from load bad website to do not load bad website. Let's run. They both pass. One browser shows self-signed badssl.com and the other browser shows your connection is not private. That's it. Thanks for watching, and I'll see you in the next session. If you're interested in more videos, feel free to subscribe to my YouTube channel and click the bell icon. Also follow me on Twitter, connect me on LinkedIn and Facebook. The transcript and code will get placed on GitHub, and I'll see you again.
Books available in paperback, ebook, and PDF. All Part 1 ebooks and PDF documents are free. Programming books for UFT. Programming books for Java. Here's a Selenium automation book. And TestNG. Subscribe to get notifications of future videos. Don't forget to like, comment, and share.